Well, howdy, howdy, howdy. This is going to be a video that talks about how to calculate wavelength, frequency, and it's going to use the constant speed of light. C is the speed of light, and it's a constant value that will always be given to you. It's 3.00 times 10 to the 8th meters per second, which is a very large number because light travels very quickly. V is the frequency, which the units are hertz, or 1/seconds, or seconds inverse, which is the same thing as 1/seconds. Speed of light is given to you, and the wavelength is this symbol here. We call it lambda. It represents the wavelength, and usually the units of those are meters. As wavelength increases, the frequency decreases. So let's look at a quick example of that. When we go from a wave that looks like the top one down to one in the bottom, we have essentially increased our wavelength. So the wavelength here versus the wavelength here. As I increase wavelength, I decrease the frequency. I decrease the amount of waves that can pass a given point in time. So we're going to go ahead and solve an equation using a word problem here. A certain wavelength of yellow light has a frequency of 2.73 times 10 to the 16th seconds inverse, or what we call hertz. Calculate its wavelength. So a triangle that I tell my students to use is like the density triangle, if you remember that. And the density triangle was used to help solve for certain variables. So if we go back and I look, frequency is V. We have C divided by lambda. Well, that looks a lot like the density equation. Density equals mass over volume. So we're going to put C on the top, frequency on bottom, and wavelength on the other side of the bottom of the triangle. So I have a frequency. I know the speed of light. I'm calculating the wavelength. So when I rearrange, I'm solving for wavelength, so I can cover it up. And what I'm left with is C divided by V. So when I take the speed of light, 3.00 times 10 to the 8th meters per second, and I divide by the frequency that was given, I'm going to get an answer of 1.10 times 10 to the negative 8th. And let's just take a quick second to look at units. I have meters per second, and I'm dividing it all by 1/seconds. And if you know anything about fractions, when you divide a fraction by another fraction, you multiply by its reciprocal, which would be seconds over 1. And from last unit, we learned that you can cancel out units top and bottom. So then we get meters over 1, which ends up being just meters. So does it make sense that our final answer is in meters? Yes. And we know that wavelength is a length, and meters is certainly a distance.